Hello everyone. I'm making this video because we lost the first 35 minutes of our recording this morning because of the network failure. This is review session number 1 for exam 2. Okay. First exam 2. Okay. Exam 2 will be this Friday. So what you need to do is you go to Canvas, you go to modules, and you will click exam 2. I'm not sure whether you can preview, you can reach this point, but if you can, you will see that the equation sheet has been uploaded. I may still modify the equation sheet. My plan is to add, not to subtract. In terms of the material, we will not do the magnetic field, do an infinitely long current carrying wire. So you don't need the last picture here. Okay. Uh, and if you can access this page before Friday, don't worry. The number of problems will be close to 15 or less. Okay. Uh, just as a reference point, last exam we had uh, 14 problems. Okay. So let's see. Other than that, one student, I think Zaid, asked me whether it will be in person. It will be similar like exam one, but if you decide to do it in class, I will not be in class. I will most likely I will be at Mayo Clinic in Scottsdale. There is a conference right there. Okay, so let's start with the problems that we did. We did a lot of iClicker problems. I think we did 9 to 10 iClicker problems today. The first slide that I want to cover is the materials, the topics. As you can see, there is no current carrying the magnetic field due to a current carrying wire. All the topics are here and they're all fair game for the exam, and if you want to get a perfect score, you should master all of these topics. Okay. And then this is the first iClicker question today. We did this problem twice. Initially, uh, about 3/4 of the students didn't get it right. So what is this problem? So basically, we have a circuit, um, and it has four identical resistors, and there are 2 points here, point A and point B. Okay. And then if I place an ammeter, which is a device that measure the current, the question is, what does the ammeter say? What is the current that the ammeter measure? Okay. Um, so to help you, what I did today is let's use red. So we started with, apologize. Something thin. So let's say if we have VA, so if we have 2 points here and some resistor VA and VB, if VA, let's say 10 volts and VB is equal to 5 volts, then the first iClicker, I ask the class whether there is any current. If there is a current, whether it flows from left to right or from right to left. And the answer is that the current would flow from left to right. And then using mechanical analog, this is similar to if we have an inclined plane, okay, and 5 meter here, and we have an inclined plane like this. If we roll a ball, then a ball will move down from 10 to 5, from the height of 10 meter to the height of 5 meter. Okay, is that clear? And then I modify the question by basically the same setup, but instead of there is a 5 meter difference, then there is zero voltage difference. So from 10 volt to 10 volts, and the question is there any currents? And as far as I remember, majority of students got it right. So there is no current flowing because the voltages or the potentials are the same. So using mechanical analog, this is like having a perfectly flat surface, and you put a ball, the ball will not move. Okay. So using this analog, I show the same problem to all of you earlier this morning, and as far as I remember, most of you got it right. The answer is C, 0. This is because the circuit is symmetric. Again, all resistors are the same. Okay. And then because of that, all the potential drops are symmetric on the circuit. And VA is equal to VB. If you go through it carefully, VA is equal to VB. Consequently, the current between AB is equal to 0. And then I mentioned to you that I consider this problem difficult, and if there is any similar problem for the exam, to me, it will be easier. But hopefully this will give you, we will paint a picture of the level of difficulty of the exam in the class, okay? Next is I discussed that one thing that I didn't emphasize or didn't give you examples is that it's about light bulb. Light bulb, the reason why light bulb is when you touch light bulb is hot, and light bulb like burning yellow. It is because basically it's a heating elements or a resistor. And then the brightness or the intensity of a light bulb depends on its power loss, and it's equal to P equal to V times I. P here is power, okay, and V using Ohm's law is equal to I times R, which is V times I is equal to I times R is equal to I square times R, and then I square is equal to V divided by I. This one is also equal to V square divided by R square times R is equal to V square divided by R, okay? So, and then I show you one problem. It looks similar to this, but I changed the wording a little bit. So basically we have two light bulbs, A and B, okay? Two light bulb, sorry, A and B, and it's connected to a potential. And then the question is, if we connect a jumper wire is this wire here, and this jumper wire, I think Ellie or Eli asked me the question whether the jumper wire has resistance or not. In this class, the resistance of a jumper wire is equal to 0. This problem is slightly different than what we did in the class. Here, When a wire is connected across B as shown, bulb A, I think in the class I asked you about bulb B. So after the wire is connected, before and after B, then the B will goes out or will be completely dark. Uh, but here the question is the question asks you about bulb A. Okay, since the resistance. Okay, how to do this? Okay, first, uh, if the electrons, if the current goes along this path, along this path here, then there is less resistors, right? So we know that VI is equal to V divided by R. So I increase as the resistance decrease, right? And then P, the power is equal to V times I. V, or the voltage, is independent of the resistors, and I, after we add the jumper wire, increase. So the P here, PA, is V times I. Basically the power increases. So the answer is that bulb A here burns more brightly. Okay. I should, so basically A burns more brightly. So the answer is A. Okay. Uh, so and then I mentioned that on the exam, I may change the drawing. You know, for example, the voltage can face the other direction. Instead of jumper wire, I can put real wire, and I can also add switch. But basically, if you understand, you can answer any problem. Okay. So this is again, this is similar problem. The answer is basically similar. Bulb A will burn more brightly. Okay, good. What else that we did this morning? And then we discuss resistors in series and parallel. And then I show you this problem. So basically, if we have a, a, a resistor in parallel, then the equivalent resistance is equal to, or the inverse of the equivalent resistance is equal to the sum of its inverse. All right. So the question is, as more identical resistors are added to the parallel circuit shown here, the total resistance between point P and Q is. So you can view it differently, different ways. First, you can do it mathematically. You will arrive at a conclusion that the resistance will decrease if you do it mathematically. But this is physics class, right? Another way to say it is that uh, if you have one resistor compared to two resistors, the resistance per path is the same, whether it goes here or goes here or goes here, the resistance is the same, but the more resistors that you add, the more path that you have, so the resistance should decrease. Okay. Uh, if you want to do it in combination between physics intuition and some math, you can do it. You can say that the voltage along this part of the resistor is the same. Before and after resistor is the same. Okay, and you can invoke uh, Ohm's law, V equal to I times R. Okay, so for that you can get I is equal to V divided by R. This is the current per path. Okay, this is current per path, and then since the sum of the currents should be the same, sorry, since sorry, the current per resistor is the same, and then if you have more and more resistors, then the amount of current will be higher. Okay, because the currents across one resistor is given here. The current across the resistor on top is also given here. The current across the resistor at the bottom also given here. Then the more resistors that you add, the more currents that you have, the total current. Therefore, if the current is higher, the current is higher, that means the resistance should be lower since the voltage is the same. Okay, and that's what is written here basically. And then finally, we're almost done. I did this problem in class, and the recording is on YouTube. Uh, and I encourage you to watch the recording. Uh, and this is the last problem that we did in class, and the recording also survived. This is the last 10 minutes of the class. You can uh, watch the recording. One thing that I forget to emphasize is that the current that was asked is at t equal to 0. So immediately after. Okay. So sometimes in physics we call it t equal to 0 plus. So immediately after 0 second. But the currents as a function of time will decay. Okay. But so okay, so I'm just gotta move it here. But the current at t equal to 0 plus is equal to V naught divided by R. Okay. So the answer is A, and we did this in the class. And finally, there is a question after class by Hannah and Eli, uh, and I what I did to them is I asked them to email me the question, and I emailed them this slide, which is part of the study guide that I will upload tomorrow. Okay, so those are the summary of the first 35 minutes of the review session 1 for exam 2. If you have any question, feel free to email me, and I'll see you guys on Wednesday.